Hello guys, we're back for 4.5 dealing with linear inequalities. Before we start off, I like to kind of explain and show you a picture of what an inequality is. Hopefully you have the Pearson module up and you're working in tandem through Pearson and with me. So here we go. A linear inequality is something that's going to look like this. It's like your y equals mx plus b form, except now there's going to be an inequality instead of the equals, and that is because it's going to model something that looks like this. So if we're looking at linear inequalities, it's going to be all the points above a line or all the points below a line, and the line is included if it has the equals, and the line is not included, and we show that by being a dashed line or a dotted line, if it does not have the or equal to. So what we want to talk about first is figuring out, is a point a solution? Now this is actually fairly easy to do because my point is just an x and a y coordinate. So go ahead and plug in the x and the y coordinate for your inequality here, assuming that you're on Pearson and working through and you've made it to this got it. So when I plug in here, I have 6 is less than or equal to 2/3 times 3 plus 4. Now the 3 I can always think of as just 3 over 1. So these 3's cancel each other. And then I get 6 is less than or equal to 2 plus 4, so 6 is less than or equal to 6. Is that true? Yes, in fact it is, so that checks out. It is a point. It would be right on the line since it's the exact same, but it would work. It is an accepted point. So pause this and think about it for a second. Suppose an ordered pair is not a solution of y greater than x plus 10. Would it have to be a solution of y less than x plus 10? Pause and think about that. And the answer would be no. The point could in fact be on the line x plus 10, and if it was on that line x plus 10, then it would not be a point solution to either of them. So try these really fast. Determine if these points are solutions. Pause the video and do this on your own. So don't come back until you've solved both of them. So when I plug in the given points for each of these, I will then have 2 is less than or equal to a -3, which is 2 less than or equal to -3. No, so this is not a solution. Then when I come over here, I have 3 greater than -30 minus 12. Well, -30 minus 12 would be -42. So is 3 greater than -42? Yes, so it is in fact a solution point here for number 2. It checks out. So as I showed you in the beginning, here's another representation and explanation for when we use each situation, where we're shading. If it's greater than, we're above the line. If it's less than, we're below the line. And if it's or equal, we shade the line. If it's not or equal, we do not shade the line. So the first step in graphing it is obviously to set up our x and our y axes. So make sure that you've worked through the Pearson module to see their explanation about all this. But then when I come to graphing this, the first thing I look at is the y-intercept. Always look at your y-intercept first, because that's the first thing to go on the graph. Then we look at our slope being 1/2, and remember this is rise over run. So my rise is going to be 1 with a run of 2 to get to my next point. I do that again, a rise of 1 and a run of 2 to get to my next point, a rise of 1, a run of 2. From there, you can basically see the pattern that we're forming and the line that we can follow. So go ahead and make that line, but we have to determine whether it is dashed or solid. And because I have less than or equal to, what do you think? Dashed or solid? That's right, it would be a solid line because it does have the or equal to. And then because it is less than or equal to, would we shade above or below the line? That is right, we would shade below the line because the less than or equal to tells me to shade below. Try number 3 and number 4 on your own. Set up the axes, draw your line, decide whether it's dashed or solid, and then shade above or below the line. We want to draw our x and y axes something like this because when I look at the y-intercept being -2, I want to be able to fit that on, and my slope being 3, that means I'm going to go up fast. When I come over here, my y-intercept is a negative value, and then my slope is negative, which means I will continue going in the downward direction. Go ahead and make sure your lines are drawn. Alright, so I set up my line with a y-intercept of -2 and a slope of 3, so I go up 3 over 1, up 3 over 1, continue on doing that. And then I shade everywhere above the line because it is y is greater than or equal to, which is also why my line is solid. Make sure you have 4 done. I'll be right back with that solution. So if you're able to tell, my line here is in fact dashed, and because it does not have the equal, and because y is less than, I've shaded below the line. Now I know it's more like to the left of the line, but if you think about leveling off the line, this is actually below it. So lines with equations that look like x is less than something or y is less than something and there's just a number, those are always going to be horizontal or vertical. So remember that if we have y is less than something, it's talking about a place vertically that it exists. So that will actually be divided by a horizontal line. And the y is talking, or the x is talking about a horizontal location, so it'll be divided by a vertical line. Let me show you an example. So x less than -5. So 1, 2, 3, 4, 5. We put our mark right there. But since it's just less than, this would have to be dashed, which I don't think my tablet is going to like. And then I continue it all the way down. And now, since x is less than that, I shade just everything to the left of it. If I come over here to y being less than or equal to 2, I would have to set up the line y equal to 2, and I can have a solid line because the or equal is there. And then y less than or equal, that means I need to shade below it. So all of those are possible values. Go ahead, try 4 and 6 on your own. So our situation about the party, where we can spend no more than $12 on nuts, peanuts cost $2 a pound, and cashews cost $4 a pound. Well, at $2 a pound, if I only bought peanuts, then I could buy 6 pounds. So I'd have a point right here, 6 pounds of peanuts for $2 each. And if I only bought cashews, I could buy 3 pounds because they're $4 a pound. So I can make a line that connects these 2 points as best as I can make a line. Now there would actually, if I get rid of a pound of peanuts, I can't buy another pound of cashews yet because there's not enough money. But if I get rid of 2 pounds of peanuts, I could buy another pound of cashews. And if I get rid of another pound of, or 2 pounds of peanuts, I could buy another pound of cashews. So actually I'm going to get rid of my line here and try to connect it a little bit better. And then if that's the most that I can spend, then we're really saying like 3. Well, really, let's look at the shading first. We're going to be shading below it. I love budget problems because this is real world. So we budget $200 for outdoor furniture. We know that cedar costs $2.50 per foot, and pine costs $1.75 per foot because it's not as good of a wood. X is going to represent cedar, and Y is going to represent pine. And we want to set up an inequality to represent our situation. So go ahead and pause the video and try that on your own, setting up that inequality. So what a budget tells me is that that's the most I can spend. I want my expenses to be less than or equal to that. So my expenses are going to come from cedar, that is $2.50 per foot. So we'll just call that, actually we said we'll use X for that. So then we set up our $1.75 for every foot of pine, and that needs to be less than or equal to 200. So now, if we want to graph the line, we can either think of the situation where we buy all cedar and or all pine, or we can get this in a y equals form. So I want to challenge you, go ahead and try to get this in the y equals form. So get rid of the x variable first, bring it over to this side, and then get rid of the 1.75, bring it over to this side. All right, if you got the line into y equals form, this is actually the simplified fraction of 2.5 over 1.75. This is using both integers, which I always find it easiest to talk about slope in a rational form. So we get negative 10/7 x plus 114.286, and that'd be awfully hard to graph on the computer because I'm getting tired of this pad. So that would be the graph that you'd be looking for, something that looks just like that. And then the amount of wood that we could have, I mean, we could have a lot of different answers for that. 80 feet of cedar, or 10 feet of cedar, 80 feet of pine, 20 feet of cedar, 50 feet of pine. I mean, there's a whole lot of different possibilities. So this is our equation, and that would be our graph that we're looking for. Now we want to be able to write an equation for a line with only knowing information about it. So We're writing an inequality, so we know it's an inequality. Boundary line is dashed, so that tells us something. Slope is 1/3, that tells us something. Y-intercept is -2, and above the line is what's shaded. So pause for a moment, try to write out this inequality right now. And hopefully this is what you were able to come up with, because our slope of 1/3, our y-intercept of -2, and if we're above the line, we are greater than. If the line is dashed, there is no or equal to. So now try 9, 10, and 11, writing the equation for those lines. So if we look at 9, we have a solid line. Y-intercept appears to be 3, and the slope, if I count rise over run, I've got a rise of -3, a run of 1. So go ahead and try to set that up. And because my line is solid, I get y is greater than or equal to -3. I go over 1, but really that's unnecessary. So -3x plus 3. Go ahead, try 10 and 11 if you have not. So what we get for number 10 here with a slope of 3 over 2 is that y is greater than 3/2 x minus 3. And remember from a couple lessons ago, hoi vux, horizontal uses y, vertical uses x. So since this is a vertical line, it uses an x is less than 3 because it's talking about the range of x values and it's cutting off at 3. All x's less than are shaded. We will discuss this question in class. There's a few different ways that they're similar and different inequalities and equations, that is. One of the biggest ones, though, is that if I divide by a negative, something special happens to my inequality, and we just reviewed that today in class, actually. So hopefully you guys understand all this. Please let me know if things are not making sense. Please do your practice work. You need to do the odds or the evens. You make your choice, odd or even problem sets from the homework. And let me know if you have issues. I will do whatever I can to help. Thank you and have a wonderful day.